Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we continue to talk about streaming I/O and the Java libraries, and in particular we're going to focus on how we deal with binary data. So in the last video we talked about how we could wrap an input stream or an output stream and use what's referred to as the decorator pattern, and we looked at how we could make a buffered input stream by wrapping a buffered input stream around a regular input stream, and how this could increase performance. Sometimes but the thing about the buffered input stream is that it really doesn't give you any extra methods. You have the same functionality, it alters how it's done. Another reason for wrapping and decorating your streams is to give you some additional functionality. Now, at a fundamental level, the fact that an input stream can deal with arrays of bytes means that you can write or read whatever you want, because everything is fundamentally goes down to bytes. However, stop and think about the problem where imagine that I have a class that has some doubles in it, and I want to write those doubles out to a file. Well, a double is just 8 bytes, but converting from a double to bytes is not all that straightforward. It turns out there are facilities inside of Java Lang. There's a wrapper for double, and there's a method inside of here that will convert it to a long as bits, or in back and forth. So there's long bits to double, and there is double to long bits, and double to raw long bits. So you can do these types of conversions on your own, but this is a common thing that you want to be able to do. You want to be able to write things out not as strings of numbers, but actually write out the double itself as just 8 bytes. And for this, there are data input streams and data output streams. So if we look at data input stream, once again, we have a constructor here that takes an input stream, just like the buffered. Because a data input stream doesn't, in a fundamental level, know what it's reading from. It can read from any type of input stream that you want. What it is intended to give you is the ability to read and write values in a binary format. So for example, you can read double, which will read in a double that was written out by a data output stream when someone called write double. Okay. Now, why would you do this? Why would you use a binary format instead of a text format? And we've seen that we can use sources for reading text, and we can use the print writer for writing text. We even saw how we could use the file input stream and file output stream and do things with text. We just had to convert it back and forth from arrays of bytes. Turns out that text is not a very efficient way to represent certain types of data, in particular numbers. If you write out a lot of numbers to a file, writing them out as text makes it so they take a lot more space. A double that is, when you print out a double, if you print out full accuracy, you'll often print out 16 digits for that. In addition to the 16 digits, you'll have things like a decimal point, possibly an exponent on there, positive or negative sign, and you have to have something in between the numbers, so an extra space or a comma or whatnot. On the other hand, the double inside of the memory of the machine is really only 8 bytes. And so you should just be able to write out 8 bytes and then read back in 8 bytes, and you have the full information for the double. Not only does it take more space, but it's really slow. The conversion from a string double to what goes into memory takes a fair bit of work. Now, this doesn't matter if you are reading in 10 doubles, but if you're reading in 10 million of them, all of a sudden the overhead of converting to and from text can start to become significant. Okay, so what this allows us to do is to deal with data more efficiently, to put it inside of a file in a way that is fundamentally closer to what's actually in the memory of the machine. And so to demonstrate this, I'm actually not going to continue along our lines here. I actually want to go ahead and let's see. Yeah, we'll go ahead and just do something that is separate. I will comment out all of this code. And I'm going to make an output stream. So one of the things, I cannot just read some text file from someplace. If this is going to be binary data, I'm going to have to create it first, and then we'll take a little second to look at it. So I'm going to make a new data output stream, and I have to pass this some other stream that it's using. Now I could just say make a file output stream and maybe give it the file name binary.bin. If I do an import here, okay. However, as we talked about in the last video, you really, for efficiency's sake, it's good to get into the habit of wrapping binary input streams and output streams around these things. Or not binary, buffered. So I am going to wrap my file output stream inside of a buffered output stream and wrap that inside of the data output stream. Okay. And the reason for doing this is, and the order here matters. Okay. The innermost one is what I'm actually pulling the data from, and the outermost one has to have the methods that I want to use. So let's say I had an array of random numbers. Or actually, let's make it so they're not random. Let's make it so they're evenly spaced. Nums equals array dot tabulate, and I'm going to put 100 numbers in here, and each one is going to be 0.1 times I. Okay, so they're evenly spaced as by tenths. Then what I want to do is I want to write those out to the file. Now I want to write them out in such a way that I know how many there are. So first I'm going to say, I'm going to write an int of how many there are, which is nums.length. And then I just noticed something on that. Oh, that was for the byte array. Okay. And then I want to write out all the values. So then I want nums dot for each os dot write double os dot close. Okay. I need the data output stream to be the outermost stream here in the wrapping, because if I were to swap this, if I were to make the buffered output stream the outer one, well, buffered output stream doesn't have a write method that can write an int or that can write doubles. Actually, this should actually be write int. If I did the other one, it would only write it as a byte. So it doesn't have a write int, and it doesn't have a write double. So if I were to swap these, in fact, I can show that. Make that one the data one, and make that one the buffered one. Now I have errors here because these methods don't exist on a buffered output stream. So when you're doing this wrapping, you need the innermost one to be where you're pulling the data from, and you need the outermost one to be the one that has the interface that you want. And then in between those, you can have other things that provide functionality, such as the buffering. So if I run this, okay, this should theoretically have created a file. Turns out if I come over here and I refresh, there we go. It's binary.bin. And to look at this, I'm actually going to create let's look. So let's go to the workspace. Just cd. cd tilde slash There it is, binary.bin. And let's look in this. And I hit enter, and it gives us this warning. You sure you want to look at this? Because this looks like a binary file. And so I say yes. And lots of what looks like gibberish. I could also look at this as a hex dump. Yeah, xxd of binary.bin. But it's binary data. It's not something that you can read, and what's more significant, I cannot VI this. Okay, so I cannot go into here and take a text editor and edit it. If I want to play with this data, I have to write a program that handles it. Technically I could come in and deal with the hex directly. That is probably not a good option. So let's say I wanted to get these values back. Well, if I comment out those, then I can say val is equals new data input stream of a new buffered input stream of a new file input stream binary.bin. Do our import here. Make sure we close the file. And then val nums equals array.fill of is.read int is.read double. Nums.for each print print line. And now we run this, and sure enough we have values that are spaced out by 0.1. Because they are doubles, you have this, they're not infinite precision, and so every so often you're rounding errors because it turns out 0.1 doesn't have a nice binary representation. So we have these are pulled out of the file. So we've just demonstrated how we can write things in binary and how we can read things in binary. Once again, this would be sufficient. We could write code that would use this to write out everything that we want. But this isn't necessarily the ideal way of reading in large amounts of data or writing out large amounts of data. So there's actually an easier way to write out whole objects. As you might have noticed in the API, we have the ability to do things like write booleans, write char, write double, write float, write int, write long. So all of the basic built-in types, what in Java would be called the primitive types, we have the ability to read and write those. But this doesn't give us the ability to read and write, say, a student. And we'll talk about what we would need to do in order to make that happen in the next video.